Okay, let's talk about pin sets. We've got a set of big pins, small pins, and the smallest pins. Take a peek at our small pin set. Each one was precision ground to a certain thousandth of an inch. The littlest one starts at 61 thousandths of an inch, and they go up 1/1000th of an inch at a time. Let's look at the biggest pin in this set, a 1/4 inch, 0.250, and the smallest pin in the set, 0.061. Look for the marking that's etched on the side, and notice that it's not just 0.250, it's 0.250 minus. And same for the small pin, it's 0.061 minus. Every pin in all three sets is a minus pin. These are minus pin sets. What does that mean? Well, put it in a micrometer and you'll see that for the 250 minus pin, it measures slightly less than the nominal stated value. That's the key idea. A minus pin promises to be less than its nominal value, the number etched on the side. They make plus pin sets with the inverse promise that every pin will be slightly bigger than the nominal value. But as a beginner, we're just going to use minus pins to get to know the fundamentals. Our pins measure at about 2/10 to 3/10 of a thousandth of an inch, less than the nominal value. And a quick check of the small pin shows that this 2/10 to 3/10 under holds for that pin as well. So what do you measure with a pin? Well, you measure round holes. It's often the ideal tool for measuring a hole because it gives you a very accurate dimension of the hole, but it also gives you a tactile feel of the fit of the hole. How wiggly is the pin in the hole, or how at risk of jamming in the hole is the pin. Here I've got a block with 8 holes in it, and step 1 is to find a pin that fits in all 8 holes. If it fits, pick the pin one size up and ask the same question: does this pin also fit in all 8? As I go, I'm having insights, discoveries about the geometry of these holes, because the next pin up only fits in some of the holes. At that point, keep going and pick the next pin up and the next until you find a pin that fits in none of the holes. And just like the light touch on the thumb wheel of a caliper or the gentle approach towards the click of a micrometer clutch, there's a degree of judgment that you've got to make when using a pin set. Questions you can ask are, is the pin descending all the way to the bottom of a hole? Or is it getting stuck halfway down? Is it encountering no resistance? Is it flopping around inside the hole? Is it encountering some resistance? Is it at risk of jamming, requiring me to exert quite a bit of force, sometimes so much that I can't get the pin back out of the hole? Each of these judgment calls requires quite a bit of experience to make properly. And so as a beginner, for now, just stop with the 2 questions: which pin fits in all the holes without me forcing it, and which pin does not fit in any of the holes? This question is the start of a go, no-go gauge. A go, no-go gauge is just 2 pins that you tape together so that they become a pair that you give special meaning to. One of the pins is small, and your expectation is that it goes in all of the holes. The other pin is large, and your expectation is that it does not go in any of the holes. And it's a great idea to give your go, no-go gauge a flag that indicates the size of each of the pins, because pins are easy to lose track of. And it's often nice to color code each side of the gauge so that you can tell at a glance which side is the go and which is the no-go. The pins are often very close to each other in size, and so it's unclear which one is the small one at a glance. Good, now confirm that it actually works. Ask, does my go pin go into all the holes? Ask, does my no-go pin not go into all of the holes? And then think about how you would use this tool going forward. If we were making 10,000 of these blocks, we could ask with this gauge, is each block still good? And of course, all of that is precipitated on the assumption that this first block was good to begin with. And goodness really depends on what you're making here. But that's the topic of another video. For now, let's just mention that if you were making 10,000 of these, you might want a sturdier handle for your go, no-go gauge. Last check, let's put this go, no-go gauge in a micrometer and make a humbling discovery. It started here when I glanced at the pin set and noticed, wait a second, there are 3 pins missing, but my set only has 2 pins. Which ones did I actually tape together? The small pin measures at 978, so that's an 098 minus pin, but I happily wrote on my flag that it was an 061 minus pin. So, tail between my legs, I am getting that errant 061 pin back in the set, and I am remaking the flag with a go of 098 and a no-go of 105. And while I could argue that I was distracted while making this video, the same argument would go that you're always going to be somewhat distracted because you'll be busy thinking about the very difficult or awesome or exciting project that you're working on. And so a commitment to a procedure of measuring and then remeasuring can go a long way towards catching these little whoopsies. When you're all done with your go, no-go gauge, measure each pin before putting it back so that you have high confidence that you really do have an 098 pin that you were putting in the 098 pocket. Great. If you're ready to take the next step from how big is the hole that I'm measuring, start thinking about roundness. Start thinking about how we can use these same precision ground pins to ask questions about how round the pins themselves are and how round our holes are that we're measuring with those pins.